This is from class number 2, and away we go. Now, one of the first things we said when we have problems that are in two decision variables, when we have x1, the number of tables, and x2, the number of chairs, we had a non-negativity constraint. So x1 and x2 are greater than or equal to 0. If I use x1 down here and x2 over here, I'm going to be working in the first quadrant with all positive values, or at least non-negative values for x1 and x2. Now we had our constraints. We had a constraint for our 1 by 1 bricks, our little tiny bricks there, and we had 4 of them went into a table and 6 of them went into a chair, and we had 40 of those bricks total. So we'll do less than or equal to 40. Now what we want to do to graph this constraint is we want to draw the line 4x1 plus 6x2 equals 40, and then figure out the less than or equal to side of the line. In order to draw this line, the easiest way to do it is to find a couple of endpoints and connect the dots. So if x1 is equal to 0, x2 is equal to 40 divided by 6, which is 6 2/3. So there's 5, 6 2/3, roughly there. And if x2 is equal to 0, x1 is equal to 40 divided by 4, which is 10, which is easy to find over here. And again, we just connect the dots. I'm just going to make my line blue so that it matches up with the writing. And let's see if I can do this. There we go. So this line here represents 4x1 plus 6x2 equals 40. And as I mentioned, we're interested in the less than or equal to 40. So we're interested in this side of the line. And where all of these feasible sides of the lines intersect will be our feasible region. So let me just change colors here and make it, I don't know, red, say. We had our next line, which is our 1 by 4 brick constraint. And again, we had 2 of the long bricks going into a table. We had 6 of those bricks going into a chair. Whoops, that should be x2. And we had 36 of those bricks in total. So again, let's pick some endpoints and connect the dots. If x1 is equal to 0, x2 is equal to 36 divided by 6, which is 6. Likewise, when x2 is 0, 36 divided by 2 is 18. So one thing you're going to notice is somewhere out here is 18. The easiest way to do this is to pick another value for x1. I'm going to choose 9. So 2 times 9 is 18. So that means x2 is going to have a value of 3 in order for this equation to work. So 9 and 3. And we said 0 and 6. So we can connect up those dots. And again, let me just change the color of my line. There we go. And we'll draw that line through there. And actually this line extends all the way down over here. And then we just have our last line, which is going to be our plates constraint. Again, I'm just syncing up the colors here. They're going to appear in purple. So we had our 4 by 4 plates, and we had 1x1 plus 1x2, and we only had 8 plates. So this line is very easy to do. If x1 is 0, this is 8. Likewise, if this is 0, this is 8. So we can draw a line from 8 on that axis to 8 on this axis. And we're done. And again, we're interested in the underside of the lines. And where all of these undersides intersect, we have our feasible region. The next thing we need to do is draw our objective function line. And our objective function in this case is Z equals $18 for table plus $15 for a chair. And the problem is we have this value for Z. We don't know what it is. So we can choose some arbitrary value. My advice is choose a number that works well with these coefficients, 18 and 15. So I chose 90. What I'm going to do is I'm going to flip over to Excel. This spreadsheet's available at WebCT. And you can see here 18x1 plus 15x2 equals $90. And I intersect at x2 equals 6 and x1 equals 5. And every point in this line represents the combinations of tables and chairs that net me $90. What I need to do with my objective function line is move it away from the origin as far as possible. So I've got these little spinners all set up here, and I just click on the spinner to increase my value of Z. So now you can see every point on this dashed green line represents a profit of $107. And we keep going and going and going until the last point in the feasible region that our line hits before we leave. That'll be our optimal solution. So we keep going and going and going. There we go. And the last point we hit is down here at 8 tables and 8 chairs. And that is how to solve the monochromatic furniture company using a graphical solution method.